So what's the net gain of ADH2 and NADH from the Krebs cycle? Is it 10 NADH and
So it's 8 NADHs from the Krebs cycle, but then total of 10 NADHs, because you also get 2 from glycolysis.
and then FADH2 is
2. Okay, so photosynthesis is really similar to cellular respiration in the processes that it uses. What's the equation for photosynthesis?
It's the opposite of it. What it is, except energy is light.
Yes. So just another form of energy there. And then you get eventually a glucose molecule and oxygen. Okay, so photosynthesis can be divided into certain steps. First step we talk about is usually the electron transport chain, which we call the light dependent reaction. Okay, second step, we'll say Calvin, which is light independent, meaning it can happen all times of the day. Right, like this only happens when the sun is shining. Light independent can happen all the time. Also part of the light independent reaction is chemiosmosis, which again looks exactly the same as chemiosmosis in cellular respiration. The only reason we need this is because we need just slightly more ATP.
The photosynthesis that's light independent skips step 1, right?
Yes, we don't do this if we don't have light. Okay, so let's talk about the electron transport chain first. So we're in the thylakoid membrane. Okay, remember the thylakoids were like the green pancakes that we ate filled with Nutella. Okay, and then we have these integral proteins called photosystem. So we have one that's photosystem 2, which is actually the first one that like the electrons come to. But it was the second one discovered, so that's why it's 2. Then you have a couple more of these guys. And then you have photosystem 1. Okay, we all remember that part of it? Okay, so water is going to come in to this thylakoid space. Okay, probably through like another protein, one of those aquaporins, remember? So water comes in because it's in a high concentration on the outside, low concentration on the inside. So this is facilitated diffusion. Okay, we'll talk about osmosis in just a second if you guys want to. But then as soon as it gets in here, it splits. So this is the hydrolysis part. So we create some hydrogen ions in here. We have some oxygen in here. And we have some just free-floating electrons. All right, so the electrons are going to go right into these photosystems. And then the photosystems are going to capture light. So remember, they have pigments such as chlorophyll A and B and carotenoids that can actually absorb the light and use that light energy to power these electrons. So the electrons are going to jump up to an electron acceptor. I'm going to draw it as like a little hat. But the electron acceptor only holds it for a second, and then as the electron starts to lose energy, the electron acceptor is like, I don't really want you anymore. So the electron gets dropped to the second photosystem, which just so happens to be photosystem 1 in this situation. What happens as this electron is dropping? Somebody else takes advantage of him losing energy.
But then isn't energy gained right on the second one?
So keep in mind, like anytime we phosphorylate something, it takes a little bit of energy to like get that P on it. Like remember, ATP is an adenosine with 3 phosphates, and this bond holds a lot of energy, but it also requires a little bit of energy to stick it on there to begin with. So the ADP and the P get stuck together as this electron is falling down. Okay, so we actually are making a little bit of ATP right here. Okay, and then that electron gets excited, and what does it do when more light comes in? Probably need to draw like sunlight in a different color. So sunlight comes into here, and then sunlight comes into the second system, and what does that electron do?
It bounces back up.
It jumps back up. Okay, but then who catches it this time? It's not just a random electron acceptor.
Oxygen?
Not oxygen. Good guess though.
Carbon dioxide?
NADP plus catches that electron, and it's able to find a hydrogen in this to become NADPH. Okay, so NADPH is the electron acceptor that photosynthesis is going to use. If ever you get confused, just think like NADH is in cellular respiration, and if you add in that P, you're making it specific for photosynthesis. So NADPH is created at the end of the electron transport
This
chain.
happens in the cytoplasm? Or
So this is happening in the thylakoid membrane. Okay, so this is happening in the stroma. So if you remember when we're talking about a chloroplast, we have these thylakoids, and then like the syrupy stuff on the outside is the stroma. So the NADPH is actually in the stroma. Okay, and that NADPH and that ATP are going to be important for later on. Okay, so those two things are actually going to be used in the Calvin cycle. Okay, so are we okay on the electron transport chain? Okay, so in the Calvin cycle, what do we start with for the Calvin cycle? CO2? Anyone? Anyone? So CO2, which is ultimately these guys here. So we've explained the water, now we're to the CO2. Okay, oh, and by the way, this oxygen from this water molecule that split, it can just diffuse straight out. Okay, which is where this comes from. Good, because remember again, oxygen is nonpolar, simple, small. It can just go right through simple diffusion and leave through the phospholipids. All right, so we're taking a 1 carbon molecule, we add it to a 5 carbon molecule. Anybody remember what the 5 carbon molecule is called? Sounds like a French guy's name.
Rubisco?
Rubisco. So Rubisco is the 5 carbon molecule. So at this stage, just for a second, we have a 6 carbon molecule. Okay, because 5 plus 1, 6. And this took a little bit of energy to add this together. But then really all the other energy stuff that we do here is just about fixing it and making it into a better 3 carbon molecule. Anybody remember the name of these 3 carbon molecules that it divides into? G3P, yeah. And these G3P look a lot like pyruvates. And so eventually, like, they're going to be glued back together to become a glucose molecule. So some of them, it's not a 50-50 ratio, but some of them are going to go into making a sugar. Some of them are going to go into, like, being recycled up to a Rubisco.
So
Okay.